Hi everyone, so we're going to be looking at topic S1.5 and we're going to be looking at ideal gases. Now, the kinetic theory of gases state that molecules in gases are in constant motion. Now, according to the theory of an ideal gas, we assume that gas molecules are moving very fast and randomly. We assume that the molecules, they don't have any volume, they have negligible volume. We also assume that they do not interact with each other. So we assume that there's no intermolecular forces. And we assume that when they are colliding with each other, the collision is an elastic collision. What is an elastic collision? An elastic collision means that when they are colliding here, they simply bounce off in opposite directions. So there is no change in energy when the particles are colliding. So we say that energy is conserved. So they collide with each other and move away in opposite directions. When the collision is inelastic, it means that some energy is lost. So then what happens, the particles will not move in opposite direction. They can stick together or they can change the direction of motion of any of these, right? So we're assuming, according to the ideal gas theory, that all collisions are elastic collisions. And here, this one is not really an assumption. This one holds true in most conditions, that temperature is directly proportional to average kinetic energy. So temperature directly proportional to average kinetic energy, which means that when temperature increases, the motion of particles increases. When temperature decreases, motion of particles decreases. Now, these assumptions are only valid for an ideal gas, and ideal gases, they don't actually exist. So it's just a model that is used to predict how gases will behave in certain conditions. So in reality, gases, they don't fit this ideal gas model, but there are certain conditions where gases come very close to an ideal gas, right? And two conditions where real gases behave as ideal gases is under high temperature and low pressure. So these two conditions, they will favor the ideal gas behavior. Now, when these two conditions are not met, we say that the gas will deviate from ideal gas model. So then it will tend towards a real gas, right? Now, normally, gases exert pressure when the gas, they are colliding with each other and they collide with the walls of the container. So whenever there is collision, there is a force that is exerted, and the force per unit area results in pressure. Now, at high pressure means, if you look at here, we are compressing this gas, we are applying a pressure here, we are compressing the piston. You can see that the volume occupied by the gas is reducing. So when the volume occupied by the gas particles is decreased, there's more frequent collisions. So here we have high pressure, so pressure is increased. And under high pressure, we cannot say that the volume occupied by the gas particles is negligible because the volume of the gas itself is reduced. Hence, the volume of the individual gas molecules becomes significant. So then, the statement that we were saying that molecules have negligible volume, this statement here will not hold at high pressure. So at high pressure, the volume of the particles become significant. So then it behaves as a real gas. So this is what is written here. The next case where you're going to have a real gas model, so it's going to deviate from ideal gas model, is at low temperature. So at low temperature, what happens? Low temperature means that particles are moving slowly, because we saw that temperature is directly proportional to kinetic energy. So at low temperatures, particles have low kinetic energy. So because they have low kinetic energy, they are going to interact with each other a little bit more, which is going to result with intermolecular forces of attraction. So the intermolecular forces of attraction start to happen between the particles, and the collisions are not elastic anymore. So at low temperature, you're going to see that this assumption and this assumption does not hold anymore. So because of this, then the gas becomes a real gas. It tends towards a real gas model.